Hello and welcome. This is a presentation for managing machine learning projects as part of the course 2 of AI product management specialization from Duke University. I'm Rav, and this presentation is being provided on October of 2024. So let's get started. So the overview of the final assignment was to identify a machine learning project and rationalize my thought process about the project, why I select that, and how I go about the entire machine learning project um, end to end. So things to consider as part of the project was to do or look at the project from an opportunity evaluation point of view. Um, and as part of this presentation, I would be walking through each one of these items, that is introducing the problem and describing why I consider the problem to be an attractive opportunity for the machine learning based solution, mainly trying to answer, is there a problem? Can machine learning solve it? And does someone really care having it solved by applying machine learning to that kind of a problem? Or are there other solutions with which we could solve the same problem? And I will also be looking at it from the CRISP DM process, in which would be defining the problem, defining the success, and quantifying the expected business impact based on the quantifying outcomes and stating the outcome and output metrics and identifying the factors which may be potentially relevant, and the solution validation plan where would I would describe what the solution concept and how it uses the machine learning, and describing how we'll execute a series of iterative experiments to validate the proposed solution concept. And we'll also try to answer some of the design consideration, the rationale behind the three key design decisions one would have to make. And then we'll also talk about a little bit on the potential risks in the production, or putting the model or putting such a model in production, and what do we foresee the possible model issues which might arise when the model goes into production. So with that, let's get started on the project that I have in mind. So looking at the project or the idea and considering it from an opportunity evaluation point of view, so the selected model or the selected machine learning project is about predicting student exam scores based on the study hours. So my selected project idea revolves around this predicting students' exam scores on the based on the number of hours a particular student dedicates towards it. We can look at it as a simple regression problem where we predict a continuous variable, which in this case happens to be the exam score, based on feature study hour. But then that's one of the primary feature. However, we have an option to consider many other feature which will have an influence in terms of predicting a continuous variable, which is the exam score for a given student. Now, why is this up? Now, why is this an attractive opportunity? Now, is there a problem? Yes, of course, there is a problem. Many students and the educators want to understand the relationship between the number of hours a student puts in and how that materializes into their academic performance, and mainly to see whether the habits are effective and whether increase in the number of hours are going to give a better exam results, or are there other factors which are contributing towards it, and to understand that is very crucial and essential. Now, can machine learning help solve it? Yes, machine learning can model this relationship. We could use the regression techniques to predict future exam scores, um, again, based on the study hours, but that's just one feature, but we will have to consider much more to be able to have more meaningful um, outcome for such a problem. Now, would someone care about this problem? Absolutely, right? So the students and the educator will benefit from such a model, and as they gain insights into how the study habits are going to influence the results, so which can help in academic planning as well as performance optimization, as well as the students to learn what and how they could do things better and improve their performance. Now, trying to apply the CRISP DM business understanding process, and as per the process, we understand to define a problem from a business objective is very essential, and also to define it in a more achievable way, more actionable way, where it is going to provide a direct insight into what this model is going to do is essential. So I would define the business objective as the goal for this machine learning model and the project is to predict the student's exam score based on the number of hours they studied in the week leading up to the exam. The success in this project not only means building a model, but also to provide insights into optimal study hours for students to achieve their best performance by highlighting the diminishing returns in study time and reduce the variance in student score after students use the model's recommended study hours, and then to be able to see that a student using the model's recommended number of hours is able to achieve at least 5 to 10 points improvements on their exam scores. So the project has a value giving students and the educator a data-driven tool to predict performance and adjust study plans for the students as well as the educators. So that would be the business impact. Now, what is the outcome? The model could help students maximize their performance by showing diminishing returns or the ideal study hours. And what would be the output metric for our specific model that we would consider? So the machine learning model, because this is of a nature of a regression, we could be looking at the root mean square error values as well as the mean average error, where the root mean square would be an indicative of reduction in the score variance across the students, and the mean average error being lower will be an indicator of the model itself to be providing the recommendations that are more reliable. Now, the factors affecting, factors which would be potentially relevant. Um, the factors in this sense is basically the features. I'll try to highlight few features, but then it's certainly not limited to this. The main feature would be the study hours, and then the other factors could be the past exam performance. That could be a secondary important factor or the feature, and then comes all the rest of other kind of features or factors we would have to consider, like the sleep quality and time spent by the students on other activities. So those all would be factors, and we would have to see how different factors are going to make any significant impact on our output metric. But then those are things to consider to begin with. Now, the solution validation plan. The solution concept, um, if related to this particular project, would involve building a simple linear regression model which uses the number of hours as the input feature and the other set of features that we were able to collect and predict the exam score as the output. So we will begin, or we can, the approach is we can start with having a small data set of the past students' study hours and exam scores to train the model, and then increase and add more features and try to see how those features are going to contribute or not for the outcome of the model. So the validation process itself would be the way how we would approach in validating this is by training iteratively. And then we'll split the data into training and test set and validation set. Then, iteratively train the model on a portion of the data, validate the model on a validation set. We check for the root mean squared values to understand how well the particular model predicts, or model is working for, and then providing the different metrics. And we adjust the data set by adding more features, and then we try the model again. Also, we could try with the different types of algorithms we would use for modeling, like the decision tree or the polynomial regression, and all in the category of the regression kind of an algorithms, and see what our model, how the model shows, and then comparing the different models and evaluating against the output metric of each of the model, we will be able to come to a particular model which gives the better, more accurate predictions. So now the design considerations and the rationale behind that, trying to answer the three questions. Um, is this kind of a model going to be a cloud or an edge model? So I think that should be a cloud. Um, Given that this project is small and focused on batch predictions, and this is where it's also a batch prediction, cloud deployment is what I would consider as the best fit for this. And using a cloud service provider as the Google AutoML, or the simple model running on a local machine would suffice. So this would be a cloud. Now coming to offline versus online learning, the response is going to be this is an offline learning, because the data is a static data that is about the student hours, and the exam scores of students from past exams are not something we would want to get into real time, but this is a static data which will be available. So it will be an offline learning, and we will train the model once, and we use it to predict the future scores. Um, Now coming to the part where whether this is a batch or online predictions, like I said, it's a batch predictions is what makes more sense. We can do the predictions in batches, after collecting a set of study hours for all the students before the exam, so we could predict all their scores at once. So there is no real need for a real-time prediction in this scenario. Now, what are the potential risks in production? So I've just tried to highlight few, and this is not obviously limited to only these. However, the training serving skew, which basically could occur if the distribution of students' study hours in production when the model goes in production is vastly different from the training data. So if we have used the training data, which isn't necessarily reflecting the realness of how many hours the students are going to put in the real life, then our model, which has been trained on the training data, is not going to work better when it gets deployed. The chance for data drift over time if the study habits and the external factors, like online education versus traditional schooling, or things like schools being shut down, and which is going to cause um, our model's prediction and the effectiveness of the features that we have used to start to become slowly irrelevant or drift. So it could lead for it could lead to a concept drift. It is a potential for such a model when it gets deployed. Um, Latency, it's not a significant factor because we're not doing any time sensitive or real online learning, but it could be a factor when the model's usage try gets scaled up. So then latency would be one of the factor to consider. But again, the reason I've captured that over here is because it's not really significant, but then it can or it will have a potential when things go as a production model. Now, how could things be mitigated? By regularly retraining the model with the newer data, newer trend, example, taking it from the recent exams, and then try to prevent the data drift, and then to keep the predictions accurate on the newer versions of the model, considering the trend and the pattern of how things are changing in the study habits of the students. So with that, I would conclude my presentation.